Welcome to the channel where all you gotta do is, well, this is a stock cylinder head from Pick and Pull. I think a 2002 Saab 2-liter. And after doing some inspection on the cylinder head that's in the Sonda, it's pretty messed up. It's finished like a couple of races that way, but it's kind of shaky. So picked up this cylinder head for $100 to the local Pick and Pull. Probably should have waited for 50% off day, but anyway, we got a track day coming up in a few months, so I wanted to get the spare head ready. So the one I already ported probably will end up going on the car, and then this one will be the spare. But either way, they're the same. So I'm gonna pop this thing apart, get it pressure washed, get it in the solvent tank, get it cleaned up. Okay, that's tight. Ooh, water just came out of that. That's always a good sign. So on these you don't have to worry about marking the intake and exhaust cam because it has this little slot in here for the distributor. This one doesn't have a distributor, but Saab was nice enough to put these little slots in here. They just have a plug in here. You just pop that out and then you can run a distributor if need be. If you have the, if you want to put this on an old style. So one of the other things that I may not have mentioned is we are putting this on a B202 engine, which is a Saab 900, like an early Saab 900 engine, and it doesn't actually supposed to fit that motor. So you have to do a little modification, both to the timing cover and to the cylinder head over here, which I'll put a picture up in the corner. I'll put it over here. To show what that entails, but it's nothing difficult. You could do it with a die grinder. I do it on the mill because I have one, but if you didn't, you could totally just grind it on the mill. And it's just clearance for the timing slippers and stuff. So one of the other things that I may not have mentioned is sometimes when you pull stuff out of the wrecking yard, it's broken already. This one, probably pretty likely that the reason this ended up in the junkyard. I mean, I'm speculating here, but this stud here, the exhaust stud, was broken. So in California, if you have an exhaust leak, it won't pass smog. And then in order to fix that, that would require somebody pulling the head off and drilling that broken stud out of there and maybe retapping it. You don't really know until you get it apart. So I have a feeling, because the rest of the car was in pretty nice shape, interior was pretty nice. It was an automatic, so I doubt it was abused. But yeah, there's this stud and this stud are both broken, and this one's a little bit shorter. So I'm gonna have to do some, easy out work. You just drill a small hole in there, and sometimes you gotta do some heating and whatever, but usually you get those studs out and it's not the end of the world. But again, this car is probably worth, I don't know, 1,200 bucks or something like that. It would have cost them more than that to get it fixed. So they just gave it to the junkyard and wrote it off on their taxes, and then I get a decent head. I didn't bother to check to see what the mileage was on it when I was at the junkyard, but I did pull the valve cover off and pulled a couple of cam caps off and kind of look at the cam, because that's usually what's messed up on these. And everything looked really good. And it needs a little bit of tap, I think. So this thing should be compressing the spring, but it isn't. And those little keepers are going to try and fly out of there. I'm just going to give it a little like that. See how it moved another, because this thing was just bending. So, which is fine. Take a little pick or screwdriver or something. Pop the keepers out of there. And we need to press this more. It's loose. Another thing I'm going to do, take a little pen light and I stick it in here, and then I can see what I'm working on. Alright, so all the valves are out. That's what all the combustion chambers look like. I think this is workable. I'll pop that sensor off of there, and then we'll give this beast a bath. Okay, so this is the spare head. I haven't ported it yet, but I wanted to, instead of grinding the idea of these seats out, I just machined them all to the same size, so they're all super consistent now. And then all my blending work is down a couple hundred thousandths below the seat. Call it 5 millimeters. So then I'm going to flip this thing around. This is on an angle plate thingy. And I have it set at 22 degrees because both of these valve angles on the Saab are 22 degrees. So now I'm going to flip this thing up the other way and do the opposite one. Now the way I did this was I jammed you could use one of those carbide thingies, but I don't have one of those in every size, so this is a 462 valve stem. I just chop the head off it and I just jam it down into the guides, and the seal on the opposite side kind of holds it centered pretty good, and then I indicate each one of these in. Okay, so this is Junkyard head. I picked up last week. It was all grungy. I did a little bit of work to it. I drilled out these three broken studs. So no new studs in there yet, but there's, I don't know if that'll focus, but there's threads in there. And then I machined out the inner diameter of the seats. So anyway, I got these guys all ported up. Okay, so here's a better look at the intake port. I guess maybe the lighting's better. And it's interesting, this stock Saab port. If you look at it really carefully, you can see right there And right there, this one's even more obvious. See that little spot there? That's a different color. There's a little ding in the port. Every one of these ports, I mean, they obviously CNC, you know, manufactured the mold with CNC programming, because you could see the lines in there where they contoured it, but they apparently didn't have a very good modeling program, and it left a little balloon dog in there, kind of a little wrinkle in the fabric of the port on every one of them. Super consistent. Okay, so this is the flow data that I got. I picked up quite a bit on the intake. Now, remember that this thing only has 8.6 millimeters of lift or something, so it's like right around here. So maybe 251 or something like that, which is good. I think it was 240 something at that same lift. But it kept going up, so in case somebody's running a bigger cam, they can utilize this data. On the exhaust, I think I had 180 something, 185 or 8 or something like that. And I floated again, and it was less. This is only 170. And I also floated it with and without the header. It picks up a little bit with the header, but not much. A few, 5 CFM or something like that. But I think what happened was the earlier test I ran, I think I had a small leak, and that affected my numbers. So I think I trust these numbers better than I would the previous video I made. So I apologize for that. But I have a football head. I really would like to get this up a little bit more. But yeah, this is where we're at right now. This is what both of the heads reported to. So this is going to be our race setup for the time being. And yeah, this one's already done it. 7 millimeters of lift. So I think this one could use more valve, which is the Swedish guy. I think his flowed 190 or something, so up in here. But he did put bigger valves in, quite a bit bigger. I think they were 33 millimeters instead of 29s, something like that. So anyway. This is what we got. Can't argue with the data. The data is the data. So this is what we're going to run. Somehow the seats are less knackered. I zoom in on it. Does it make it worse? Yes, it does. Oh, there we go. Yeah, those are FUBAR. So I will break out I won't break it out, but I'll pull the cover off of it. I'm going to clean up these valves. So, got my valve grinder over here. And, yeah, it's an oldie, but it is functional. So, okay, so this is my old Sioux Falls valve grinder. I don't know, came over on the Mayflower kind of thing. So it's got this kind of old school chuck on it, which is pretty cool, but I don't super trust it, because sometimes you put it in and it's got a thou of run out, and sometimes it's got 2 tenths, and sometimes it's got 5 tenths. So I checked every one. I put my indicator in here, and just kind of stick it in here and kind of jiggle it around, make sure there's no dust on it. And then I take my cordless drill, and I just have like a 1/4 inch socket in here, X bit, and I kind of spin this over, and I look at the indicator there. And it's about 3/10,000ths of an inch or something like that. So that's pretty good. It's usually within, less than a thou, but sometimes that's not good enough. So you just take it out and kind of wriggle it around, put it back in again, and that's fine. So this is the dresser to dress this wheel. This side over here is when you're done doing all the valve faces. You can stick it in here and cut the end of the valve. I don't usually use this thing because I'm only taking a thou or two off usually here. So hydraulic adjusters take care of that, no problem. But some old engines, that's how you adjust the valves. You grind the end of the valve stem. So that's what this is for. I did fix my skid steer seal with this, so it is useful. This just backs this in and out. Turn this thing on. Got transmission fluid in it for coolant, which is fine. This little diverter valve is when you make it squirt out of this side or this side. And then one thing you want to make sure you do is always keep this moving. Don't just grind in, because grinding wheel is basically made out of a bunch of little rocks, and you don't want to like locate on that same area where a little rock is sticking out, because you'll get a groove in it. So, like some cam grinders and crank grinders, the wheel actually has like a little shift to it. There's like a little cam, so the grinding wheel moves back and forth, so you don't get that problem. At least my Landis cam grinder that I had many years ago, it moved about 30 thousandths left to right. So, you know. So anyway, you just have to do that by hand. Crank this guy in. There we go. Anyway, so that's looking pretty good. Okay, so back on this Saab 205 head, different than a 204 head. I'm not sure what, but has a different casting number here than a 204, and it came on a later model. I think this is a 2003 that it came off of. But this needs to be modified to clear the timing chain tensioner guide thingy, the little plastic dude that you can't buy anymore. So you have to machine the slot from here to here, 2.4 inches, and from this edge of this bolt to where the new spot's going to be is 0.46 inches, and then 1.68 deep. So take a look at this guy here. You can see it's that deep. Okay, so I got both of these cylinder heads all ported up. The race head and the spare head. Did a couple other modifications to it. I drilled out these plugs and tapped it. So I still need to kind of wash this a little bit, deburr it and stuff. And I also threaded this because this is our feed line for the turbo. So that's how that other head was. This is the one that came off of this Honda. I've never done this before. I've never cleaned these out, but the reason I did it is twofold. One, when you're porting it and whatever, cleaning on stuff, you can make some chips and get down those holes, and this is the main oil feed to the lifters. So I wanted to kind of clean that up. And second, when the bearings for the cam get screwed up, it's always the same. It's always the farthest away from the oil feed. So the oil feed is right here, and then the oil comes in here, goes across this cross drilling here, and goes down here to feed all these, and goes down here to feed all these. But this one is the one that has the most losses, more turns and farther away, and it's kind of the last bus stop. So that's the one that always gets messed up. So, I mean, we're doing terrible things to this thing, you know, racing it and stuff, but even ones you find in the wrecking yard, they have the same problem. That's always the worst one. So I think what we're gonna do is put a hose between here and here, and then it'll have a second path, right? It'll be feeding both of them, but it won't be necessarily, maybe it'll make this one fail. But anyway, we're gonna try just jumpering this to this, see if that fixes anything, and if it doesn't, we'll just plumb oil pressure directly from the pump to that and see if that helps. So, I mean, it's a minor limitation. These Saab engines are pretty robust. I remember when I used to work at Garrett in the 90s, they had Chrysler engines, the 2.2 single cam Chryslers, and they have Saab engines to run on the dyno to try to wear out the turbos. And they would go through about every 100 hours, they would have to replace the Chrysler engine. And these ones lasted about 500 hours. And this is like, you know, it's kind of a torture test for the motor, but they'd have to go through 5 or 6 Chrysler 2.2s to go to the end of life of a turbo, and then they'd only need like 1 or 1.5 of these. Literally there were pallets of Chrysler 2.2s just piled up, and that's why, you know, I was walking through the dyno shop one day and I asked Steve Martin, he was the manager of the dyno cell, not the comedian, different guy, and I said, well, why do you have a giant pallet of motors over here? And then he gave me the whole scoop. He says, yeah, we tried to do all the testing for the Chrysler turbo with Saab motors, but they wouldn't let us. They said we had to use Chrysler motors because, I don't know, exhaust gases are different or something. But he said it was, yeah, we agreed to it. And then we're like, well, that was stupid. Now we literally send pallets of these motors to engine rebuilders to go through them and, you know, put new rings and bearings and valve seats and yada, yada, yada. So anyway, they're fairly robust motors, but that's one of the things that we've had an issue with. The other thing is if you overheat them, the heads warp, and then, I mean, you can cut this face, but the cams are still crooked. So you got to make sure it's not too bent. Like sometimes if it's twisted, it's okay. You can cut the face and it's fine, and then the cams aren't crooked. But you really need to, you know, take your straight edge, precision one, don't use a Home Depot straight edge, and just put it across the cam towers and make sure it's, you know, it's level and stuff. So the other thing we got going on today is, besides we have to do a little bit of cleaning, I made a little valve seat install-y tool. It's just pretty simple. To put new of these guys in. These are the old guys that came out. So you just I put a little grease on there to hold it in, and then you just boop, push it in. And these ones are old, hard as a rock. So anyway, we're going to do that. This is, you know, a Junkyard head, so it's probably got 150,000 miles on it, something like that. All right, time to do some assembly work. New seals. New razor blade. Just making sure that they're all seated all the way, because if they're not, the keeper retainer assembly will smash into it and then might not seal after that. All looks good. So I'm putting a little bit of grease on this thing not to lubricate the steel, just to keep it from falling out, because gravity's working against me, or partially against me here. By the way, if you don't have a pair of these pliers to remove them, you should probably get some. Makes it way easier. You can use like needle nose vice grips and stuff, but these are better. There's probably, you know, good brands and bad brands, but they're all better than vice grips probably. I haven't ordered any Temu parts, so that might not be true. Okay, now looks good. So now I'm gonna throw the valves in. Before I do that, I'm gonna put some of this as engine assembly lube. This doesn't necessarily have this stuff in it. I refilled this with, you know, high zinc stuff, motor oil, like break-in motor oil. So, but this has a nice little spigot on here, and you close it up, keep the dust out of it, and you can just, so that's what I use. You can use whatever you want. So this is going to be super hard to film, but basically stick the light in there, and then take a little bit of grease, put it on the keeper side, and then a little bit more grease to hold it to the screwdriver. You don't have to use a screwdriver, you can use whatever you want. And then you put the one on the bottom, and then that holds it in place. And when you're putting the second one on, that one goes on the top. So you got a gravity assist, so you just have to make sure that slides in there and doesn't fall out like that there. Now I put WD-40 on these things, so they're a little bit more slimy than ordinarily they would be. But I didn't want them to rust because I cleaned them in solvent tank and then water. So anyway, those are in there. Pop the light out. And then just double check, because if these things come loose, you're in deep doo-doo. So those are in there nice. Yeah, it should look like that. Not sure if this will help. Alright. Main thing about this is don't forget to put any parts in. You need all the parts. You need all the parts. There we go. Alright, so I got this thing all assembled. I forgot to wash the bolts that hold these caps down, so those are in the solvent tank. So I got this kind of covered up so turkey poop doesn't land on it, but I wanted to kind of show one of the later additions. So this is the lifter from an early head, which is fine, but you can see how that cavity there is all, it's like that whole thing is full of oil. There's a big donut shape kind of full of oil in there. So this is, it's going to have more oil in it. I don't know how much is drained out, but that weighs 62.3 grams. And then this is one from the newer head. I don't know if you can see that without some illumination. Let's see that little bumpy right there? Right there. So that is lined up with this little hole on the side, which is what lets the oil in. So as you can see, the cavity down there that has oil in it is much smaller. So that other one was 63 grams. This one's 50 grams. That's a pretty significant change. I think the valves weigh. Let's see, what do the valves weigh here? Intake and exhaust are exactly the same, so yeah, that weighs 55 grams. That's the entire valve. So this weighs almost as much as the valve. This weighs more than the valve. So making these light is an advantage, right? Less spring force needed, less force needed to actuate, right? So anyway, this is the newer style. If you're building one of these, probably make sure you got one of them instead of one of these old styles, which is just full of oil. And this is probably bled down. This probably isn't full. I don't know, but that's definitely an improvement. So anyway, this thing's about ready to go. I'm just going to slam the cams in as soon as those bolts are cleaned up. And yeah, I'll have to clean up some adapters here. Bolt that on, get the RTV seal in, put the ITBs on it, all that junk. So just to let you know, I didn't really show how I put the lifters in, but I just cleaned them, lubed them up with fancy lube, and lubed up this bore inside here and pop them in. It's pretty darn simple. I'll go back with some acetone and get rid of these numbers. Those don't need to be there. But I wanted to put them in the same bores that they came out of. Probably doesn't need to, but it can't hurt. Anyway, that's about it on this guy. The only other thing I need to do is I'll probably make a piece of wood for the bottom face of this, and then put some head bolts through there so we can ship it without worrying about scratching this sealing surface, because that's just going to be our spare head. And then I want to change the studs to make it so they're all the same, because some of these Saabs have a different number of long studs and short studs on the exhaust side. So I want to make those so they're all the same. So if we do have to swap this head out in the middle of a race or the evening of a race, whatever, that we're not fiddle-futzing around with all kinds of other more shit that we don't need to. So anyway, that's where we're at. If you have any questions, don't forget to put them in the comment section. And as usual, don't forget to subscribe to the channel. We're at I think we're at about 850 as of yesterday. Probably 850 and a half today. Need to get to 1,000 to get monetized so I can get my $3 check every month. You know, that goes towards my coffee and soda water budget. Not much else, I don't think. But anyway, that's one of my goals, is to get monetized, whether it's $5 a month or $50 a month. I'm not expecting it to actually pay any real bills, but when I started this, that was my goal. Been about 2.5 years now, I guess. I've been doing it for real. So I've been over 4,000 hours in a year. Quite a long time now, for the last almost a year, I guess. So that's not the issue. I just don't have enough subscribers. So if you go ahead and poke that button, it helps a lot for the algorithm. And then as soon as the algorithm helps, then we can do more learning and maybe some more cool projects. Who knows?